Hello everybody, another important lesson. It's kind of in the middle of a series of lessons that's building. I can rewrite fractional exponents as radicals and vice versa using radicals are fractional exponents and power over the root. It's going to be quick. Let's get right to it. Whenever I see a fractional exponent, radicals are fractional exponents. Radicals are fractional exponents. So if I see a fractional exponent, I can rewrite it as a radical. Whatever is being raised to the power goes inside, and the exponent is always the power over the root. So the power is 2. That's what the x is being raised to. The root is 3. That's the index of the radical. That's your answer. I put it inside of a radical, power over the root. Number 2, x goes inside the radical, power over the root. The power is 3, the root is 4. Twists. If you don't have, it's not really a twist actually. We'll see on the other end. The other direction, radicals are fractional exponents, power over the root. So the power is 4, the root is 3. Make sure the power is going over the root. That's it. Radicals are fractional exponents. I see a radical. I rewrite it as a fractional exponent, power over the root. If there is no power or root written, there's an imaginary 1 as a power, and there's an imaginary 2 as a root, because it's the square root. So the imaginary root is 2. So power over the root, power is 1, over the root is 2. So that's just rewriting it, going back and forth between the two directions. Now we're going to talk about how we can use this to evaluate integers to fractional exponents. If I want to evaluate 25 to the 1/2 power, well, radicals are fractional exponents. Power over the root, so the power is 1, the root is 2. So now I can evaluate this. Always do the root first, and whatever that is, raise it to whatever power. So the square root of 25 is 5. To the first power is 5. You can use your calculator as needed. Number 27, radicals are fractional exponents. So I put the 27 inside of a radical, power over the root. So the power is 2, the root is 3. Evaluate the root first, the cubed root of 27. If you don't know the cubed root of 27, you can do alpha Windows 6 and type in whatever root you need to find. Cubed root of 27 is 3 to the second power. 3 to the second power is 9. That's it. Let's just do one more. 81 to the 4/3. Radicals are fractional exponents. Power over the root. So the power is 3, the root is 4. Do the root first, the 4th root of 81. If you don't know what that is, alpha Windows 6, 4th root of 81 is 3. To the 3rd, again, you can use the calculator if you need to. 3 to the 3rd is 27. Now, could you, for everything we just did, well, this whole last set, could you have just done 81 to the power of 3/4 and gotten an answer? Yes, but it could ask it to you in a way where you're not going to be able to do that. Like numbers 31, 32, and 33. This is how I like to ask it on the regions sometimes. Explain what a rational exponent such as 5/2 means. Well, it's always the same answer, and it's all in our song. Radicals are fractional exponents. And the exponent is always the power over the root. So whenever it says to explain anything talking about fractional or rational exponents, rational exponent is just another phrase for a fractional exponent. Radicals are fractional exponents, power over the root. So now if I want to evaluate this, I put the 9 inside of a radical. Power is 5, root is 2. Do the root first. The square root of 9 is 3 to the power of 5. Use a calculator if you need to. 3 to the power of 5 is 243. So there's a set of problems like this. It's always the same thing, always the same explanation. And then to evaluate it, that's what we just did. So radicals are fractional exponents. It's always the power over the root. You may need to just go back and forth with x's like we did in the first section here. Or you may need to evaluate using actual integers, which we just did as well. That's it. It needs to be practiced. You'll see it come up. It comes up in the SAT. It obviously comes up in Algebra 2. Practice it. Goodbye.